Assalamu alaikum, everyone. My name is Muhammad Shazib, and in this video, I'm going to explain my smart parking system project developed in C++. And this project is based on file handling and ESP32 serial communication. The system can store parking records. We can set their records by putting their spot IDs, and we can update and replace their records as well. And we can even receive parking IDs from ESP32 automatically. Now let's start the complete code explanation step by step. So here's our C++ code, and in the library section, you can see first of all we include some important header files, and first one is IO stream. uh, that is used for input and output operation like cout and cin. And the next one is f stream, that is used for file handling because our project stores parking records inside a csv file. And the third one is s stream, and which help us to separate CSV data using commas. And the fourth one is string, that is used to for string data type. And the fourth one is window.h, that is very important because it allows serial communication with ESP32 and through COM port. And the last one is C string, that is used for function like strlen. So the next structure of our code is we add records. Uh, and now here we created a structure named records. This structure stores all parking related information in organized form. Uh, inside the structures, you can see sport ID, vehicle number, and owner name and status. Sport ID stored parking sport ID, and vehicle number stores vehicle registration number, and vehicle type stores whether the vehicle is car or bike or anything else. And in owner's name stores vehicle owner's name, and in status stores whether vehicle is in or out. Using structures make data management easier and cleaner. So the next part, initialize database function. Now uh, this function is used to initialize the database. Here we open the CSV file name, you can see, and the program checks whether the file is found or not, exist or not. If the file is missing, the program displays database file not found. Then the file is closed properly. This function ensures that our database is available before program execution. So in the next part, program will check unique IDs. This function checks whether a parking ID is unique or already in database. First, the CSV file is open, and then we skip the first line because it contains headings. After that, the program reads every line. Then using string, and the program separates data using commas. Then it extract ID from the file, compare it with entered ID. If ID is matched, then it will show the record. It means if ID is matched, it means duplicate ID already exists. So the function returns false. Otherwise, after checking all records, the function returns true. This prevents duplicate parking spot IDs. And the next part, append record function. This function is responsible for adding new records into the database. The file is opened in the file is opened in iOS app. Append mode means new data will be added at the end of file instead of overwriting previous data. Then the new record is stored in CSV file format, and then the program. Then the new record is stored in CSV format. Finally, the file is closed and success messages displayed. So they in search by IDs when user entered ID. So this function search parking records manually using spot ID. First, the database file is opened. Then the program skips the heading line. After that, it reads every code line by line. Again, strings in separate CSV file, and the current ID is extracted and compared with entered ID. If matching ID is found, the complete record is displayed on screen. If no matching record exists, then the program display record not found. Uh, in the update record, this is important. Now, now this function update existing parking records. Since direct editing inside CSV file is difficult as we temporary file method, first the original database file is opened, and then a temporary file named temp.cv CSV is created. Then the heading line is copied into temporary file. After that, the program reads every record. If record ID matches enter ID, then update data is written into a temporary file. Otherwise, all data is copied normally. After completion, both files are closed, and the original database file is deleted, and temporary file is renamed as the original database file. This way, the update data replace old data successfully. Here you can see. And in the next section, display all records. This function simply display all records and stored in a database. The CSV file is opened, and then every line is printed one by one. This allows user uh, to view all parking records together. And in the next section, I will explain the function of ESP connection. This is one of the most important parts of the project. This function checks whether ESP connected or not. First, we create a serial handle using create file function. The COM4 is port is used because ESP32 is connected on COM4. If connection fails, the function immediately returns false, and after successful connection, Uh, after successful connection, serial communication settings are configured here. Baud rate is you can see the baud rate is 11,050, 11,500 and 200, and byte rate is 8, and stop it rate is 1. Parity is set to none. You can see. And these settings must match ESP32 serial monitor settings. Then menu timeout settings are configured for reading and writing operations. Next, the program waits for ESP32 reset using sleep uh, function, then communication buffer is cleared. After that, the command checks ID is sent to ESP32 and the program waits for response from the ESP32. And otherwise, if data is received successfully, the function returns true. Otherwise it uh, huh. Otherwise, yes. The otherwise it returns false. This function basically verifies hardware communication between computer and ESP32. So in the next part, get key from ESP32 key function. This function receives parking IDs from ESP32 automatically. Again, serial communication is established using COM4 port, you can see, and all communication settings are configured. Then the command send key is sent to ESP32. ESP32 sends parking ID back to computer. The received data is stored inside character buffer. Then buffer data is converted into strings and extra new line characters are removed. One second, sorry. Okay, then buffer data is converted into string. Extra new line characters are removed using erase function. Finally, the received ID is returned. This allows automatic searching of parking records through ESP32. So this one we can see. Yes. So our next part is login system. In login system, now here we have implemented a simple login system for security purposes. The program asks for users to enter username and uh, here program asks to user to enter username and then asks to enter password as well. And if entered credentials match predefined values, login becomes successful, and otherwise access is denied. The program will not execute further. This prevents unauthorized access to parking system. So the next part is in main function. Main function. Now we come to the main function which controls the entire project. First, the computer program checks ESP32 connection. If ESP32 is connected, the program terminates immediately. If connection is successfully, login system starts. After successful login, database initialization function runs. Then a menu-driven system is displayed. The user can select uh, different operations like add record, search record using ESP32 key, update record, display all records, and exit. So we can search manually by by entering sport IDs, and we can search using ESP32 as well. Update record section, we can update any record at any time. So option 1 is used to add new parking records. The program asks for sport ID, vehicle number, vehicle type, owner name, and their status. Then data is stored inside database. Then the option 2 is use enter sport ID and program search record from CSV database. And the third one is success records using ESP32. This ID is automatically received from ESP32 and searched inside database. Option 4 is update existing parking records. User enters update information and database gets modified. Option 5 it displays all stored records, and option 6 exits the program safely. So this was the complete explanation of my small parking system project using C++ file handling, CSV database management, and ESP32 serial communication. This project demonstrates concept of structures, file handling, and searching and updating reports, and serial communication, and hardware and software integration. Thank you for watching this video. And in this part, I will explain ESP32 part of my smart parking system project. This ESP32 works as a communication device between hardware and my C++ software. It sends and receives parking IDs using serial communication. And first of all, we define a variable called parking ID, as you can see, P001, and which represents a parking slot or vehicle ID stored in the ESP32. Now, in the setup function, we initialize serial communication using serial dot begin, and you can see the number 115200, and we add delay of 3 seconds, and then after that we print ESP32 ready, as you can see. So in the loop function, now the main logic is inside the loop function. Uh, here ESP32 continuously check if any data is coming from serial communications dot using serial dot available, and in reading command, you can see, then we read the incoming command using serial dot read string until. This means ESP32 reads the full message until it reaches a new line. After that, we use trim. Uh, yeah, after that we use trim to remove extra spaces or new line character. And in the command, we send if ESP32 receives the command, it sends back the current parking ID. Right now, it will print P001, and this is used in my C++ program to fetch parking ID from ESP32 automatically. And in command to check connection, the second command is check ID, as you can see. And this if ESP receives the command, it responds with connected, and it shows connected. And this is used to check whether ESP32 is connected or with the computer or not. And in the command 3, we set new ID. The third command start with set slash ID, and this is used to update the parking ID from the computer. So when the command is received, the ESP32 extracts the new ID using substring function. Then it updates the variable parking ID. After updating, it confirms by printing new ID set, as you can see, and then prints the updated ID. As condition, if ESP32 receives any unknown command, it simply responds with invalid command. And how it works, this helps in debugging and ensures only valid commands are accepted. And so basically, this ESP acts like a smart communication bridge. It does three main things: sends parking ID to computer when requested, and check connections with the C++ program, updates parking ID when instructed. This makes my smart parking system interactive between hardware and software. And this is how the ESP part of my smart parking system works. And in the next part, I will show how this ESP32 connects with my C++ program for full system integration.